Lesson 2. Measurement and Scientific Tools. Reading Guide. Key Concepts. Essential Questions. Why did scientists create the International System of Units, SI? Why is scientific notation a useful tool for scientists? How can tools, such as graduated cylinders and triple beam balances, assist physical scientists? Vocabulary. Description. Explanation. International System of Units, SI. Scientific notation. Percent error. Description and explanation. Suppose you work for a company that tests cars to see how they perform during accidents, as shown in Figure 4. You might use various scientific tools to measure the acceleration of cars as they crash into other objects. A description is a spoken or written summary of observations. The measurements you record are descriptions of the results of the crash tests. Later, your supervisor asks you to write a report that interprets the measurements you took during the crash tests. An explanation is an interpretation of observations. As you write your explanation, you make inferences about why the crashes damaged the vehicles in specific ways. Notice that there is a difference between a description and an explanation. When you describe something, you report your observations. When you explain something, you interpret your observations. The International System of Units. Different parts of the world use different systems of measurements. This can cause confusion when people who use different systems communicate their measurements. This confusion was eliminated in 1960, when a new system of measurement was adopted. The internationally accepted system of measurement is the International System of Units, SI. Key concept check. Why did scientists create the International System of Units? SI base units. When you take measurements during scientific investigations and labs in this course, you will use the SI system. The SI system uses standards of measurement called base units, as shown in Table 1. Other units used in the SI system that are not base units are derived from the base units. For example, the liter used to measure volume was derived from the base unit for length. SI unit prefixes. In older systems of measurement, there usually was no common factor that related one unit to another. The SI system eliminated this problem. The SI system is based on multiples of 10. Any SI unit can be converted to another by multiplying by a power of 10. Factors of 10 are represented by prefixes, as shown in Table 2. For example, the prefix milli means 0.001, or 10 to the power of -3. So, a milliliter is 0.001 liters, or 1/1000th liter. Another way to say this is 1 liter is 1,000 times greater than 1 milliliter. Converting among SI units. It is easy to convert from one SI unit to another. You either multiply or divide by a factor of 10. You also can use proportion calculations to make conversions. An example of how to convert between SI units is shown in Figure 5. Measurement and uncertainty. You might be familiar with the terms precision and accuracy. In science, these terms have different meanings. Precision is a description of how similar or close repeated measurements are to each other. Accuracy is a description of how close a measurement is to an accepted value. The difference between precision and accuracy is illustrated in Table 3. Students were asked to find the density of sodium chloride, NaCl. In 3 trials, each student measured the volume and the mass of NaCl. Then they calculated the density for each trial and calculated the mean or average. Student A's measurements are the most precise because they are closest to each other. Student C's measurements are the most accurate because they are closest to the scientifically accepted value. Student B's measurements are neither precise nor accurate. They are not close to each other or to the accepted value. Tools and accuracy. No measuring tool provides a perfect measurement. All measurements have some degree of uncertainty. Some tools or instruments produce more accurate measurements, as shown in Figure 6. Scientific notation. Suppose you are writing a report that includes Earth's distance from the Sun, 149,600,000 kilometers, and the density of the Sun's lower atmosphere, 0.00000028 grams per cubic centimeter. These numbers take up too much space in your report, so you use scientific notation, a method of writing or displaying very small or very large numbers in a short form. To write the numbers above in scientific notation, use the steps in the beige box on the right. Key concept check. Why is scientific notation a useful tool for scientists? Percent error. The densities recorded in Table 3 are experimental values because they were calculated during an experiment. Each of these values has some error because the accepted value for table salt density is 21.65 grams per cubic centimeter. Percent error can help you determine the size of your experimental error. Percent error is the expression of error as a percentage of the accepted value. Scientific tools. As you conduct scientific investigations, you will use tools to make measurements. The tools listed here are some of the tools commonly used in science. For more information about the correct use and safety procedures for these tools, see the Science Skills Handbook at the back of this book. Science Journal. Use a science journal to record observations, write questions and hypotheses, collect data, and analyze the results of scientific inquiry. All scientists record the information they learn while conducting investigations. Your journal can be a spiral-bound notebook, a loose-leaf binder, or even just a pad of paper. Balances. A balance is used to measure the mass of an object. Units often used for mass are kilograms, kg, grams, g, and milligrams, mg. 2 common types of balances are the electronic balance and the triple beam balance. In order to get the most accurate measurements when using a balance, it is important to calibrate the balance often. Glassware. Laboratory glassware is used to hold or measure the volume of liquids. Flasks, beakers, test tubes, and graduated cylinders are just some of the different types of glassware available. Volume usually is measured in liters, L, and milliliters, ml. Thermometers. A thermometer is used to measure the temperature of substances. Although Kelvin is the SI unit of measurement for temperature in the science classroom, you often measure temperature in degrees Celsius. Never stir a substance with the thermometer because it might break. If a thermometer does break, tell your teacher immediately. Do not touch the broken glass or the liquid inside the thermometer. Calculators. A handheld calculator is a scientific tool that you might use in math class, but you also can use it in the lab and in the field, real situation outside the lab, to make quick calculations using your data. Computers. For today's students, it is difficult to think of a time when scientists or anyone did not use computers in their work. Scientists can collect, compile, and analyze data more quickly using a computer. Scientists use computers to prepare research reports and to share their data and ideas with investigators worldwide. Hardware refers to the physical components of a computer, such as the monitor and the mouse. Computer software refers to the programs that are run on computers, such as word processing, spreadsheet, and presentation programs. Electronic probes can be attached to computers and handheld calculators to record measurements. There are probes for collecting different kinds of information, such as temperature and the speed of objects. Key concept check. How can scientific tools, such as graduated cylinders and triple beam balances, assist scientists?